Hi dear students, this is part 2 of this June Perfect Paper 2022. So these are the tough questions. If you haven't done part 1, make sure you do part 1 first. The paper is in the description below. Make sure you download it as a PDF and go ahead and try the questions. Some of the questions are super spicy, so make sure you try, do your best, and if you can't do them, then go through the solution. Hopefully this is useful, and we can start from question 13. Let's jump right in right now. So question 13 here is reasonable. It's a question that has to do with cumulative frequencies. Remember that cumulative frequency is adding the frequencies. So from 0 to 20, well, we have 7 people. These are ages of people in a train. Okay, so, and then how many people are between 0 and 30? Well, we have 25 and 7. So cumulative, meaning we add those values together. And how many people do we have between 0 and 40? Well, those 32 plus an extra 20, so this will give us 52 people. And then between 0 and 50, we have an extra 14 people, so this gets us up to 66. And between 0 and 60, we have an extra 8 people, so this gets us up to 74. And then finally, we have another 6 people for the entirety of the people on the train carriage, which is 80. Okay, so with this table in mind, perhaps make a note of these points, and I guess we have to do a CF graph next. So yes, draw a cumulative frequency graph for your table. So you have to go ahead and use the millimeter paper provided to you. Let's jump right to the graph. Okay, so we're graphing cumulative frequency against age here. I would recommend you always start from 0. Okay, so always make sure that you put the numbers on the right-hand side of the interval. Now, this question is a little bit tricky because instead of being 0 to 10, so there's no kids on the carriage, or there might be, but it looks like the first interval is 0 to 20. So your first enclosure or your first annotation here should be on the 7, which is right above the 20. So let's be a little bit careful. There's actually no annotation on the 10. And the 30 will have an annotation of 32. So that's to represent the next one. And then 40 will be 52. That should be good for our graph. And 50, so from 40 to 50, 50 will be the 66. So the 66 is going to go right above the 50 here. And for the next one, 60 will be 74. So 60 is 74, which is here. And we should end up exactly in the corner with 70 and 80. Okay, this is wonderful. Now you can go ahead and connect these points together, and remember that it's important to draw not just a straight line but a smooth curve. And so we're going to go ahead and do that here. This is reasonable. And so keep drawing it. By hand is totally fine. It's absolutely great. If you want to use a ruler, that's okay too. But this should be like a rounded type of graph. So if you use a ruler, it might look a little bit too edgy. This is okay. It's not perfect, but it's okay. So I guess we've completed part B. On the graph, use your graph to find an estimate for the median age of the 80 people. So the median age is going to be the age in the middle. Drawing a line across, we realize that 40 seems to land around 33. So we can estimate the median age to be 33. So answering this question here, 33 years. Now be aware of the fact that in your exam, if you get the age right within 1 point, that should be pretty good. So we'll accept 32 to 34 bracket. So if the right age exactly was 32, then 33 will be accepted. And in the next section it says, of the trained people in the train carriage, 60% of those who are aged between 18 and 65 are going to work. None of the other people in the train carriage are going to work. So using our graph again, what we should do is find an estimate for the number of people who are between 18 and 65. And looking at these values, it looks like the 18 seems to project at 5 here. And if we look at 65, the 65 looks to project just above 75, so 76, perhaps 77. It seems like my green line is a little bit on the low side to finish. So if I was to move my green line up a little bit, I could see that this projects more towards 77 than 76. So I'm going to say that this is going to be more accurately 77. And so if we think about this, how many people do we have between 5 and 77 people? Well, 77 minus 5 is 72 people. So we have 72 people, but we don't want all 72. We want 60% of those. So we're going to say 60% times 72, so 60% of 72. And we can say 72 times 0.6, which is equal to 43.2 people. So if we're thinking about a number of people, we can say 43.2, but I would say that probably 43 is a little bit more accurate. So we're going to round this to 43 people since we're talking about human beings. Again, you'll get marks for completing your graph accurately. You'll get marks for doing a nice estimate. And if you're within 1 point of the right number of people, you should be okay. On to question 14 here, which is an algebra question with a triple bracket expansion. You could take this in any order, noticing, however, that you have a negative x in the first bracket. This is going to be a negative cubic function. You could probably get away with expanding the last 2 brackets first because they're positive and it's nice. So I'll go ahead and do that. But if you did the first one times the second bracket, it would be totally fine. So let's do 2x times x, which is 2x squared, and 2x times 4, which is 8x's, followed by 3 times x, which is 3x's, and 3 times 4, which is 12. Before you go ahead and multiply that by the first bracket, I would recommend you put the 8x's with the 3x's in the middle so that you have 11x's here. So let's do that first. So 5 minus x, factor of 2x squared. So plus 8 plus 3 is going to be 11x's, and then we have the 12 here. And now we're going to go ahead and distribute. Now this is very similar to the FOIL technique, and you're going to have to do 5 times everybody and negative x times everyone. So if I just draw some arrows here for you to understand, the 5 is going to have to be multiplied by 2x squared, and then 11x, and then 12. And the negative x will have to do the same thing. So essentially you're multiplying everyone by everyone. And with that in mind, 5 times 2x squared is going to be 10x squared, and 5 times 11x is 55x's, and 5 times 12 is 60. Followed by negative x times 2x squared, which is negative 2x cubed. Be careful, because x times x squared is x cubed. And negative x times 11x, which is negative 11x squared. So I would recommend you figure out first if it's negative or positive. So a negative times a positive is negative. And then do the numbers. So 11 times 1 is 11. And then x times x, which is x squared. And for your last one, negative x times 12 is negative 12x's. So grouping this, starting from the highest power of x, we're going to see that we have 2x cubed first. So we'll say negative 2x cubed. And then thinking about how many x squares we have, well, we have 10 minus 11. So the x squared coefficient is going to be this one, and we can group them together. So what is 10 minus 11? Well, 10 minus 11 is negative 1. So negative 1x squared is just going to be negative x squared. And then we can write our x's. So x's we have 55, and then we have negative 12. So 55 minus 12 is going to be 43. So we have 43 x's. And then for our last value, we'll have 60. And this is a great place to stop for this question, as you've organized it all in descending powers of x. Excellent. Well done. 3 marks for that question. In part B here, we're requested to make C the subject. That means you need to get to C equals. And so the best way to do that is to start by moving the minus 7 to the left, which will give you G plus 7 equals C plus 3 over 4 plus C. The next step here looks a lot like moving the 4 plus C to the left. Remember, divide becomes times. So we can say G plus 7, factor of 4 plus C is equal to C plus 3. So far, so good. Expanding the bracket here, we can say that 4G and probably CG, because you need to write them in alphabetical order, plus 28 plus 7C is equal to C plus 3. Now this is the step where you need to make sure all your C's are on the same side and all the numbers are on the same side. So I would move all the c's to the left and all the numbers to the right. So let's leave the CG on the left, and we have the 7C on the left already, so we can move this here, and we can move the C to the left as well. Now all the C's on the same side. We can keep the 3 on the right, move the 28 to the right and becomes a negative 28, and we can also move the 4G to the right, which will become a negative 4G. Simplifying here with coefficients where we can, 7C minus C becomes 6C, so we can say CG plus 6C equals 3 minus 28, which is a negative 25 here, minus 4G. And here we can do the skill step, which is to factorize by C on the left-hand side, as you realize that there's a single C here and another C here. So we can pull that out here and say that this is C factor of G plus 6, which will be equal to negative 25 minus 4G. And for the last step, you can move the G plus 6 to the right and say that C is equal to minus 25 minus 4G divided by G plus 6. And this will be a good answer to place in your answer box here. So negative 25 minus 4G divided by G plus 6. So that the teacher knows that you've got the right answer. So you can circle it if you want to. And this is good for 4 marks on question 14. Question 15, another wonderful algebra question. Okay, so solving this, most likely we need to put the left-hand side on the same denominator, which is 6, and then move that 6 to the right-hand side so that we can simplify for x. So how do we put these two fractions over 6? Well, the first fraction can be multiplied by 2. And the second fraction can be multiplied by 3. So multiplying my first fraction by 2 here, I should get 8x plus 10. All of that is over 6. And multiplying my second fraction by 3, I should get 9 minus 6x. All of that over 6 as well. And this is equal here to 13. Now when two fractions are on the same denominator, I'm allowed to put them together. So I can say that this is 8x plus 10 minus 9 plus 6x. So make sure to distribute the negative to everybody, because the negative was in front of the fraction, but now it's actually being incorporated in the fraction. So we can say plus 6x here, and all of that is over 6, and this is equal to 13. Moving the 6 to the other side, I will have 6 times 13. Now you can do this operation first. 6 times 1 is 6. 6 times 3 is 18. So this is 60 plus 18, which is 78. So that's nice. And then 8x plus 6x. So 8 plus 6 is 14x's. 14x's, and 10 minus 9 is a positive 1 here. So I can move this positive 1 to the other side and say 14x's is equal to 78 minus 1, which is 77. And it's interesting to note that 14 has a 2 and a 7, and 77 has a 7 and an 11 inside. So I can say x is equal to 77 over 14. Now this is not the most simplified version. So if I was to divide both the top and the bottom by 7, 77 divided by 7 is 11. 14 divided by 7 is 2. So this is actually going to be 11 over 2. In the mark scheme, 5.5 will be accepted as well. Make sure that you plug this back in if you want to double check, and if you have time. If you don't, this seems like a reasonable answer, so that's okay too. Part B says solve the inequality 2y squared minus 7y minus 30 is negative. So this is a quadratic equation. And so the best way to solve a quadratic equation with a number in front of the y squared value is to split the middle term. So how do we do that? We say 2 times negative 30 is equal to negative 60. And we look at coefficients which might make negative 60 a multiple of a pair of numbers, and those numbers should add up to negative 7. So 60 is a nice multiple to work with when you think about 12 and 5. So perhaps you could split the middle term as negative 12 plus 5, because negative 12 plus 5 and negative 12 times 5 are going to be the product, and the sum, which are going to work with 60. So this is going to be the product. So product of negative 60, which will add up to a sum of negative 7, which is what we want for the middle term here. So it's important to know this technique. You're looking for numbers that multiply to negative 60 and add up to negative 7 so that you can split the middle term. Now, how does middle term splitting work? Well, we're going to go ahead and do that now. We're going to change our 7y in minus 12y plus 5y. So 2y squared minus 12y, so this is the split, plus 5y, so we're splitting the middle term, minus 30. So we've rearranged this equation here, and we're going to package both sides separately. So this is going to be one packet, and this is going to be a separate packet. So in this first one here on the left, we can factorize by 2y, and if we factorize by 2y, we have y minus 6. And for the second packet that's underlined also in green, you'll have 5 factor of y minus 6. And if you factorize this by y minus 6, you're left with 2y plus 5. Now this is quite handy because you can solve this equation. So trying to think about ways in which this is going to equal 0, you can say y minus 6 equals 0, or 2y plus 5 equals 0, y equals 6, or 2y equal negative 5, and this will lead you to y equals 6, or y equals negative 5 over 2. So solving this quadratic allows you to find the two spots on the axis which, well, in this case it's going to be the y-axis, so this is quite interesting, is going to allow you to find the two spots on this axis where the quadratic crosses the axis. So if I was perhaps to draw it for you, so I've drawn here coordinate axes of which usually you'll have the x-axis horizontally and vertically you would have the y-axis. However, here we're solving an equation in y's, and so I've taken the liberty to write the y-axis as the horizontal axis, and this is just so that we can represent the quadratic on this equation and understand when it's negative. Realize I've highlighted negative in yellow highlighter up there to show you that we're looking at values for which this equation is going to be smaller than or equal to 0. In other words, when it goes below the horizontal axis, which is labeled y here. Well, we should put our two intersection points. This is a 7-mark question, so this is why it's a little bit tricky. Our two intersection points, so the first y intersection point here is negative 5 over 2. And the second y-intercept is going to be y equals 6, which looks to be here. Now, in between those two values, you'll figure that the function is negative strictly. Now, in between those two values, including those two values, the function is smaller than or equal to 0. So let's draw a little dotted graph here, and we have to just sketch it. It's not important that it's exactly perfect. So this is what the parabola would look like. And I'd like you to realize that in between negative 5 over 2 and 6, this is when this expression is going to be smaller than or equal to 0. And this is what the solution set will look like. So in order for you to get the marks, you should say that y should be contained between negative 5 over 2 and also between 6, including the values negative 5 over 2 and 6. Because if y is equal to negative 5 over 2, the expression will be equal to 0. Now we're saying smaller than or equal to 0, which means equal 0 is also accepted. You don't just reject the solution 0. 0 is actually fine. And all the other values between negative 2.5 and 6 are going to be negative, and that's totally fine, which is what we wanted. And we get 7 marks here. Now I know this was a tough question, but if you've managed to understand it and if you can practice it on your own, you can do it too. All right, good job, good job. Moving on to question 16 here, we have 100 farmers. This looks like a Venn diagram question, which is great. We should be able to do this as long as we fill in the circles. 100 farmers have either goats, G, sheep, S, or chickens, C, on their farms. Okay, so the best thing to do is to start from the absolute middle, which we don't have. But maybe we can start with 31 have sheep, which is S, 53 have chickens. We can't write any of that down for now. 6 have goats, sheep, and chickens. Oh, we do know. Okay, 6 have goats, sheep, and chickens. That's the intersection in the middle, so that's great. We can put that down. 11 have sheep and goats. So this is this first oval here. So sheep and goats add up to 11, which means that since we know that 6 is in the middle, this should be a 5 here. So 5 and 6 is going to add up to 11. 17 have sheep and chickens. So sheep and chickens is going to be the 2 circles on the right. And if it's 17, 6 plus 11 is 17. So this is nice. 18 have goats and chickens. So there's not much for us to figure out here. 6 plus 12 is 18. So this is goats and chickens. And 18, okay, we've done that. 20 do not have any goats, sheep, or chickens. So 20 have none of the above. So 20 is on the outside. 31 have sheep. So we should be able to complete the sheep Venn diagram. 5 plus 6 is 11. 11 plus 11 is 22. So there should be 9 remaining here to add up to 31. 53 have chickens. Okay, let's do the chicken one, which is the bottom circle. 12 plus 6 is 18. 18 plus 11 is 29. And we need to get to 53, right? So we need another 24 here. Let me just double check that this is correct. 24 plus 6 is 30. 30 plus 12 is 42. 42 plus 11 is 53. Okay, super. So using this information, complete the Venn diagram to show the number of farmers in each appropriate subset. So I guess we've done that, and we know that we have 100. So I guess the last point is to try and figure out G here, which we don't know. So let's figure out G. So 20 plus the whole set of chickens here, that'll be useful because we can just use the 53 number that we have for the C set. So 20 plus 53 is 73. And we can add the 5 and the 9. So 20 plus 53 is 73. 73 plus 5 is 78. And 78 plus 9 is 87. So 87 means we should have 13 people here. So that just means that everything has to add up to 100. I would encourage you to double check that. It seems pretty reasonable. So in the first section it says find the number of elements of G. So the number of elements of G are going to be 13 plus 12, which is 25. 25 plus 5, which is 30. 30 plus 6, which is 36. So we can say this is 36. The number of elements of G union S, so whatever is G and S, and then you see the dashed here, that means what is not G and S. So if we go ahead and look at G and S, so G and S looks a little bit like this. This is G and S. And you can see here that whatever is not G and S is going to be the 24 and the 20, and that's going to be 44. So to answer this question, we can say 44. The number of elements of what is not G intersecting with C. The number of elements of what is not G, so let's color in G. So whatever is not this, which means everything else, and the items which are also a part of C are going to be these items in purple here. So the 11 plus the 24, which is 35. So for question 3, we can say 35 here. One of the farmers who has chickens is chosen at random. Find the probability that this farmer also has goats. Okay, so now we're not talking about the universe anymore. We're talking about the universe of people who just have chickens. So it's the probability of what we call goats intersection chickens divided by the probability of chickens, or more simply looking at the graph, it's the number of people who have goats in the group of chickens. So let's go and have a look. So reducing our universe to the group of chickens, so we're now only considering this universe, which is actually a universe of how many people do we have here? We have 24 plus 6, which is 30, 30 plus 12, which is 42, 42 plus 11, oh, we have 53 here. So 53 is people who have chickens. Now the number of people who have goats in this is 12 plus 6, which is 18, so 18 for the goats. So it's 18 out of 53. So those 18 people who have goats inside of the universe of chickens, so 18 out of 53. So this is a conditional probability question, so we can just say 18 out of 53. Okay, wonderful. If you were to use the formula here, you could also say that this is the number of people who have goats intersection chickens, so 18 out of 100 divided by the probability of chicken, which is 53 out of 100, and you would find the same result. I think that the way that I explained it to you here is using a little bit more logic, and sometimes that's quite useful because the probability of this event, it's dependent on being in the group of chickens. So all you need to do is reduce your universe from 100 to 53 and think about what the percentage out of 53 would look like. So it's exactly the same process. The first one would be using the formula, and the way that I showed you is just to understand that it's 18 out of 53. So moving on in good spirits to question 17, feeling good as we've done so many good questions. M varies directly as the cube of h, so we can say that M is connected to h through some variable k that we don't know, and because it's h cubed, we can say M is equal to kh cubed. So we're given some information here about h and M, so we can say 4 is equal to k times 0.5 cubed, and 0.5 cubed is going to be 5 cubed, which is 125, so 0.125k, and that's equal to 4. And if I move the 0.125 to the other side, by the way, 0.125 is just 1 over 8. This would be a good way to do it. Actually, I'm probably going to do that. I'm going to say 4 is equal to 1 over 8. Okay, so I'm just changing this decimal into a fraction. The 8 can move to the left. 32 is equal to k. So find the value of h when m is 500. You now know that m is equal to 32h cubed. So that's your formula which you can use. So you can say m is equal to 32h cubed. And using this formula, find the value of h when m is 500. Okay, so we can do this. We can say 500 is equal to 32h cubed. So we can continue here with 500 over 32 being equal to h cubed. And perhaps we can divide both sides by 4. So we can say 500 divided by 4 is 125. And 32 divided by 4 is 8. And this is equal to h cubed. And this is a spot when knowing your cube numbers is quite useful. 125 is 5 cubed. 8 is 2 cubed. So when you perform the cube root of 125 over 8, you get 5 over 2. So remember, to cancel out cube, you need to cube root. And it so happens that 5 cubed is 125 and 2 cubed is 8. I would recommend that you learn your cubes, at least up to 5, so that you recognize situations like these. Question 18 here, work out the upper bound of the value of x. So this is a very interesting point, upper bound. So upper bound meaning the biggest value that x could have. So the biggest value that x could have is when 2a is maximized. So whenever this value is maximized, and the b value should be the smallest because you want to subtract the smallest amount that you can to have the biggest number that you can. So b is smallest, so I'm going to say b is minimized. So these are just notes that we can tell ourselves. And then if you want the x value to be really big, you want the divider to be really small, so we can say f is minimized as well. So using those three components, when we start this question, we can try and think about how we can achieve that. So if a is contained to one decimal place, so let's say that a is equal to 7.5, we can say that the minimum value for a would be 7.45 or greater. So these are all the numbers that get rounded up to 7.5, and it has to be strictly smaller than 7.55. Now for the b value, correct to 2 decimal points, the b value is going to be nested in a similar way. So to 2 decimal places, 3.415, that'll get rounded up to 4.2. And if you had any number bigger than 3.425, then those numbers would get rounded up to 3.43. So to 2 dp, this is good. And to the nearest whole number for f here, f is going to be contained between 1.5 and 2.5. So 1.5 is good, and 2.5 is also good. So now we can go back to the original notes that we made. So 2a is maximized, which means I want this version of the 2a. And for my b, I want the minimum version for my b here. And f is minimized, so I want the 1.5 here. So with all this in mind, I can go ahead and do my equation and see what I come up with. So x should be equal to, for the upper bound, 7.55, so 2 times 7.55, minus the b value, so minus 3.415, and then I need to divide this here by 1.5. Okay, so I can use my calculator here. Using my calculator, I find 7.79 for the upper bound of x. So I can go ahead and say 7.79. Again, think about highlighting your work at the beginning so that you explain to your teacher clearly that you know what you're doing. Remember, the examiner does not know your mental processes. So if you explain it on your paper legibly and clearly, you're showing that you have an understanding of the question. And if you want a number to be really big, you need to divide a big number by a small number. If you want a number to be a really small number, you need to take the lower bound divided by the higher bound. So that's just a logical step. And in terms of upper bounds and lower bounds, think about which numbers get rounded, for example, for a to 7.5 correct to 1 dp. If the number was 7.6, in terms of rounding correct to 1 decimal place, think about the numbers, for example, for a that will get rounded to 1 decimal point. So if you had 7.56, would that get rounded to 7.5, or would that get rounded to 7.6? Which number is the boundary? Well, it so happens that 7.55 is the boundary. Anything equal to 7.55 or above will go to 7.6. The number 7.54 will go down to 7.5. And this is how this works. So for question 19 here, let's continue, and we see that we have an expression for a in terms of x, and we see that we have an expression for x in terms of y, and it says express a in the form py plus q over ry plus s. So we notice that there's no more x's in that form. So it looks to me like all we need to do here is to put the expression for x inside of the first equation. So we're going to take this whole expression here, and we're going to plug this inside of the x value here and try and rearrange, and then find the coefficients of p, y, q, ry, and s. So presumably it's going to be a little bit of algebra, but we just need to take a deep breath and start, and we should be okay. So we're going to say a is equal to 14 over, and so make sure that you keep plenty of space here because you have a big bracket to involve. There's going to be some fractions and some work to do. 7 divided by 4y minus 3, and this is a whole fraction here, and this is minus 7. So let's start here. So the 14 stays at the top, and then at the bottom we're going to have 3 times 7, which is 21, over 4y minus 3, and the 7 here is not on the same denominator, so we need to put the 7 over 4y minus 3, and the way to do that is to multiply top and bottom by 4y minus 3. So let's do that. So everybody over 4y minus 3. So it looks a little bit tricky, but it's not too bad. So here 14 over, and so the 21 is here, and we need to expand the second bracket. So minus 7 times 4y is minus 28y, and minus 7 times minus 3 is plus 21, and all of this is divided by 4y minus 3. Now for our next step here, we still have 14, so we're going to keep the 14 at the top, and we're going to divide that by, so 21 plus 21 is 42, minus 28y, and this is divided by 4y minus 3. Now, important to note here that 4y minus 3 is at the bottom as a fraction, so it's like a whole number. If you notice the structure of the initial question, we have 14 divided by a fraction. And so when you divide by a fraction, you can flip the bottom fraction around. So if you have a divided by a fraction b over c, you can say that that's a times c over b. So it'll be pretty important here to flip the b over c into a c over b and turn it into a times. So we're going to do that now. So instead of dividing by 4y minus 3, so we can do that in the next step so that we don't get confused. So 4y minus 3. So let's go ahead and flip the fraction around and turn it into a times. So we can say 14 times, so 4y minus 3 in brackets, all of that divided by 42 minus 28y. And so 14 times 4 is 56, so we'll have 56 y's at the top, minus 3 times 14, so 3 times 14 is going to be 42, and all of that is divided by negative 28y plus 42. And we can think about common factors here. It seems like everybody is divisible by 2. 42 is not divisible by 4. 28 is made up of a 4 and a 7. 56 is made up of a 7. There's actually 7s everywhere here. So probably the best divisor that you'll find is 14. A little bit difficult to spot, but there's definitely a 14 inside of everyone. So we can divide these numbers. Perhaps if I divide it by 2 first, then you'll see that we can divide it by 14. So dividing 56 by 2, you get 28 y's, and 42 by 2, you get 21. And you see here, negative 28y divided by 2 is negative 14y, and 42 divided by 2 is 21. So for your final answer, which is what you're going to write in the A equals box, you can take this result and divide it by 7, as 28 is a multiple of 7, 21 is a multiple of 7, 14 is a multiple of 7, and 21 is a multiple of 7. So A is 4y's, and then 21, so minus 3, divided by negative 2y's, and then 21 is going to be a 3. And I think this is exactly the form which the question was requiring with p's and q's. We can scroll up and look. So py plus q, ry plus s, where all these numbers are integers. So highlighting the idea of an integer, which is a whole number value. And as we notice here, 28, 21, 14, and 21 are integers. And when you divide that by 7, 4, negative 3, negative 2, and 3 are all integers as well. Woof! Tough question. This one, very good algebra. It has to do with fractions, it has to do with flipping fractions around, multiplying, plugging in, and realizing at the very beginning of the question that the whole expression is in terms of y. 3 marks for this one. Question 20. So question 20 shows 4 identical circles drawn inside of a square. We're given a region which is a shaded region here, which is 40. The best thing to do here is to find an expression for the radius, since the radius connects everything together. So I've marked the radius in red for you, and as we think about each one of the circles and the perimeter of the shape, we'll be able to work that out, and even the area of the big circle, all of that based on the radius. So let's think about how many radiuses fit in each one of the parts of this question, and we should be able to do this. So the area of a circle is going to be pi r squared, and since we have 4 circles, we can say 4 times area of circle is equal to 4 pi r squared, and that should be an expression for the 4 white circles. So we have the 4 white circles down. For the area of the square, so the area of the square is equal to width times height, or you can say so length times length. Now noticing here that we have 1 radius, but if we look at the side length of the square, which is actually what we're looking for, we have 4 r's. So 4r is the side length. So it's a square of 4r by 4r, which means that the area of your square is 4 times 4, 16. This is 16r squared. And so when you look at the area shaded, which is given, so the shaded area, so we can say the shaded area 40, that's equal to the area of the square, which is 16r squared, minus your 4 circles, which is 4 pi r squared. So 4 pi r squared. And this is a good place to start to figure out what r looks like. So dividing everybody by 4 here, we can say 10 is equal to 4r squared minus pi r squared. On the right hand side, factorizing by r would be a good idea so that we can get a look at what r might look like. So 10 is equal to r squared factor of 4 minus pi. And we can say that if I move this to the other side, 10 divided by 4 minus pi is equal to r squared, and r is equal to plus or minus the square root of 10 over 4 minus pi. Now, it's important to notice that we're only going to take the positive square root because r is a length. In the question, we don't want to find just the radius of the circle. We'd like to find the perimeter of the square. Now, each length of the square is given to you by 4r. So the perimeter of the square is going to be 4r plus 4r plus 4r plus 4r, which is actually 16 r's. So 16 r's. So we can say, therefore, perimeter is equal to 16r, which is 16 times the square root of 10 over 4 minus pi. And so now we need a calculator. The question says 3 significant figures, so make sure that you round it to 3SF. And looking at the output of the calculator here, it looks like the perimeter is 54.61, and to 3 significant figures, I would say 54.6 is really good. So let's write 54.6 here and be happy with this question. Making sure that we have everything right, that we have indeed 16 r's for the perimeter. This was a very nice question, a little bit of insight into how to label things. Everything is connected by the radius of the circle, noticing that we have 4 radiuses as the side length of the square, and that is what goes through, that one circle is 2 radiuses. Yeah, that's perfect. So that's really nice. It's a great question. Really good for question 20. So in question 21 here, this is a vector question. We're asked to figure out the ratio AQ to QB, which means we have to find an expression for AQ in terms of QB and possibly find a ratio like 5 to 7 or 2 to 1, or it looks like 1 to 3. Now we have another piece of information, that is that OP is a scalar of OQ because they're on a straight line. So we can say that OP is equal to some constant K times OQ, which means that if you were to multiply OQ by 2, for example, maybe you would get OP. So this is something to bear in mind. So if there's a direction vector that you find for OP, a scalar of that will be a direction vector of OQ. That means you can multiply that by a number and it'll have a similar direction. This is going to be most likely the point where this question happens. Let's write some facts here. So we know we're given by the question that the vector AP is equal to 2a. Remember to put arrows on your vectors plus 8b's. So this is just stating a fact from the question. We know, or at least we can figure out the vector OP quite reasonably. So because we have OA and we have AP, so OP by the chain rule is going to be equal to OA plus AP. So this is okay to say that OP is OA plus AP. So you can add them end to end. So that means that OP, the vector OP, is equal to 4a's. And then we have AP here, which is 2a plus 8b. So 2a plus 8b. And that'll tell us that the vector O to P is 6a's plus 8b's. So that's the vector OP. So the hard thing to figure out here is going to be QP or OQ. So the bit that's difficult, since we already have the vector 4a, which is OA, is the AQ portion. And so we need to think about AQ being a fraction of AB. So let's do that. Let's go ahead and assume that AQ is equal to some multiple x of AB. This is going to be a good place to start. So OQ is going to be a portion of this, and OQ, we can say OQ is equal to OA plus AQ. Okay, so far so good. Again, we know OA, but we do not know AQ. Okay, it's important to stay methodical in a question like this, so we can say OQ is equal to OA, and OA we know to be 4A, so we can say that, plus AQ, and AQ is x times the vector AB. Now bear in mind here that the vector AB, again you can break things down with vectors, is the vector AO plus the vector OB. So the vector AO is negative 4A because it goes in the other direction to OA, and then plus the vector OB, which is just 6B. And we can use this value here for AB when we're doing XABs. Okay, so we can replace the value of AB here with this. So we can say OQ is equal to 4A plus x times the value of AB, which is negative 4A plus 6B. Okay, so we can do that. So we'll realize here that we'll have a vector going in the A direction. So in the A direction, we'll have 4 minus 4x. And in the B direction, we're going to have 6bx as we open the bracket and multiply by x and group the things which are in the A direction and group the things which are in the B direction. And this is going to be important because if, remember we're looking at OQ here from O to Q. If the vector OQ has a similar direction to the vector OP, one is a multiple of the other. And we already know that the vector AP is 2A plus 8B, and we've calculated the vector OP. We know this, look. We know that OP is equal to 6A, so 6 in the A direction, plus 8 in the B direction. So it should be really that if you think about the vector OP as a multiple of the vector OQ, so remember this is the vector OQ here. If you think about these two as multiples of each other, the 4 minus 4x should be equal to, so I'll equate the quantities for you. The 4 minus 4x will be equal to the 6 here because they're going in the A direction. And if you think about the vectors which are moving in the B direction, the 6b here, or the 6x rather, will be equal to 8. And so I would encourage you to use fractions and to say that that's true. So we can conclude here that 4 minus 4x over 6x is equal to 6 over 8. And as we do that, so this is just based on the fact that they're in a straight line. This is the key to this question. As we move the 8 to this side, we get 32 minus 32x equals 36x. And I can say here that 32 is equal to 68x, which would bring us to x being 32 over 68. So 32 over 68 is equal to x. And dividing the top and the bottom by 4, we will get 8 over 17 is equal to x. Okay, so we know the ratio, which is x, and x is the ratio. Remember, AQ is x times AB. AQ is x times AB. So if you think about it, AQ is 8 over 17 times AB. It's 8/17. It seems like it's a little bit less than half. So AQ equals 8 over 17 times AB. Now this is kind of what we wanted, but if we want to express this in a ratio, we can say that 8 parts out of 17 and 9 parts out of 17 is going to be equal to a ratio of 8 to 9. So remember, when you do ratios, you add them together. So 8 to 9 means 8/17 to 9/17, and that's a good place to stop for this question. So this is going to be our ratio here, since it's 8/17 as a fraction. So we can just write 8 to 9 here. and that's good for 5 marks. This is a tough question, definitely a difficult question. Well done if you managed to do it. Question 22, ABCD is a kite with diagonals AC and BD drawn on a centimeter square grid with a scale of 1 cm for 1 unit on each axis. A is a point with coordinates -3, 4. The diagonals intersect at M, which is coordinate 0, 2. Given that AB equals AD equals 6.5 and the x-coordinate of B is positive, find the coordinates of the points B and D. I would encourage you to draw this immediately on a graph. So let's do that. All right, so after a little bit of graphing here, we come up with a shape which looks like this. So we have A, B, C, D. Now remember that these should be written in order. AB is equal to AD. They have the same measurement, which is 6.5. We can assume that BC and CD are also the same. We don't really need the diagonal AC. It's not so important here. So I think this shape is more related to ABD, like what happens in the top. And we see here that we have a midpoint M, which is on the y-axis. And we have the coordinates of A. So we don't have that much to go with. We do know that the x-coordinate of B is positive. So B is probably on the right-hand side, going up a little bit. And so let's just assume for now that B has coordinates X, Y, and we don't know much more about it. The two key points to this question are going to be the gradients of the line AM and the distance AB and AD, which is the same, which is 6.5. So these are the two components, and most likely we'll get an equation with two unknowns, X and Y, knowing that X is positive. And with the line AM, we should be able to find the perpendicular to the line AM, which is the line BD. And again, using that piece of information with B being X and Y, we should be able to cross-check and find the solution for this question. So let's first find the equation of the line AM. So the gradient of AM is going to be the rise over the run. So from A, we rise, we were at 4 and we go down to 2. So we've gone down by 2. And for the run, we go from -3 to 0. So we go across by 3. So the line AM has a gradient of -2/3. Remember, when we look at a gradient, we look at rise divided by run. So we didn't rise, we went down by 2, from 4 to 2, the y values. And for the run, we went from -3 to 0, which is 3. Now the equation of AM, so y is equal to ax plus b, and a in this case is -2/3. So y equals -2/3 x plus b, and we are lucky enough that the b value is the y-intercept and m is the y-intercept at 0, 2. So we could actually just plug that right in and say the y equation of am is -2/3 of x plus 2. So this is the equation of am. It might come in handy, and we'll see what we can do with it. Now the perpendicular line to that, so yp, the perpendicular line to am, will have a negative reciprocal gradient. That means that you flip the -2/3 around, so it becomes 3/2, and when it's negative, it becomes positive. So perpendicular lines have negative reciprocal gradients. And so for the perpendicular line yp, realize here as well that the y-intercept is also m, so it's also going to be +2. So we have two linear equations here which are quite handy. We have the perpendicular line, which is essentially, this is the line db, so we can say here this is the line db or bd, and this equation here, which is the equation of the line am. So we have two linear equations which we found, and those might be useful since B is definitely on this line, and if it's on the line yp, it satisfies the equation of the line, which means if you have an x value, then the y value will be output by 3/2 times x plus 2. So that's one piece of information about B, which is quite useful. The other piece of information about B which we have is the distance and the length from A, which is 6.5. So continuing with that idea, the distance formula is the square root of the differences in x squared plus the differences in y squared. And the differences in x between a and b, we can say, so the square root of, so b has x coordinate x, so we can say x minus the x coordinates of a, which is 3, so x minus minus 3 is x plus 3, and that'll be squared, plus the coordinates of y, which is y minus 4. So we're left with this, and that's squared as well. So the distance d is equal to 6.5. So we can scroll down a little bit here. So we can say that this distance here is 6.5. So for our distance formula here, we'll need to get rid of the square. So we can say 6.5 squared. And you can use your calculator for that. 6.5 is quite a nice square. It's 42.25. And that's going to be equal to x plus 3 in brackets squared plus y minus 4 in brackets squared. So we're lucky now that we have an equation here in terms of x's and y's, and we have another equation here also in terms of x's and y's. B is definitely on the line BD, so it satisfies the equation of the line, and B also satisfies the distance equation, the distance between A and B, which was 6.5. So it's interesting here because we can use this substitution and replace the value of y by that whole 3 over 2x plus 2. So even though this looks a little bit scary, this is the kind of work you're going to have to do for this question. And so you just grab your seatbelt, grab your pen, don't be scared, and just get started. There's a lot of skills here, and we need to make sure that we showcase that we know so that we can get a 9. This is where the 9 is gained. So 42.25 equals, how do we square x plus 3 squared? This is x squared plus 6x plus 9. If you've made it so far in this question, you know how to expand x plus 3 squared. Plus, so y minus 4, changing the y into 3 over 2x plus 2 minus 4 and squaring it, making sure we move the 42.25 to the left. So we can say x squared plus 6x. What is 9 minus 42.25? So 9 minus 42.25 is negative 33.25. So we'll have here negative 33.25. And then squaring this bracket, we can do this in the next step where we have 3 over 2x minus 2 squared. So focusing on squaring the bracket, we can say 0 equals x squared plus 6x minus 33.25. And then as we square the bracket, again, a squared minus 2ab plus b squared. So a squared is 9 over 4 x squared, 2ab's. So 2 times 2, which is 4. 4 times 3 over 2 is 4 divided, is negative 6, right? So we'll have minus 6x's in the middle and then plus 4 to finish. Okay, so we can put the x squares together. We have 4x squared over 4 plus 9x squared over 4, which will give us 13x squared over 4, so 13x squared over 4. For the x's, we'll have positive 6x's minus 6x's, that goes away. And then for the numbers, we'll have 33.25 plus 4, which is 29.25 negative, so minus 29.25. Okay, looks like we're getting somewhere. We can move this quantity over to the other side, and we'll continue this on the next page. So 29.25 is equal to 13x squared over 4, and multiplying both sides by 4. So 117 equals 13x squares, and dividing both sides by 13, 117 divided by 13, and here you are praying, absolutely praying that 117 is divisible by 13. And it is, it's a 9. Oh my God. Okay, this is fabulous. 9 equals x squared. Be careful, 3 is equal to x. Remember in the question that it says x was positive. So we have the coordinates. Now the rest should be a piece of cake now because we've done the hard work. So the x coordinate of b is a 3 here. And if you were to find the y coordinate of b, well, you could use the line BD. So we can do that. We can say that since x is 3, so we use the yp equals 3 over 2x plus 2. So 3 times 3 over 2, let's find a little space to do this calculation. Now I would recommend that you use rough paper, but we're going to do these calculations here on the side because we don't have rough paper to work with. So we're going to say this, so 3 over 2 times 3 plus 2, so that's going to give us the y coordinate, which is 9 over 4 plus 8 over 4. So 9 over 4 plus 8 over 4, 2 is 8 over 4, right, is going to give you 17 over 4. So this is going to be the y coordinate. So B has coordinate 3 over 4, 17 over 4. And a thing that you know here is that D is on the other side. And remember, we're looking for the coordinates of B, but we're also looking for the coordinates of D. And D is equidistant to B, so the midpoint is 0, 2. So how far do you have to be from 0, 2 for the x coordinate to be 0? Well, you can simply use averages here, and that's quite nice. So if you're 3 away positive on the x value for the midpoint to be 0, so remember the midpoint is m, right? So the midpoint is everything here. This is like becoming the most important thing to finish this question. So because the midpoint is 0, 2, the D value is going to be negative 3 because the midpoint is exactly in between the x value of B and the x value of D. So 0 is exactly between 3 and negative 3. So that's nice for the x value. For the y value, it's a little bit more complicated because it's 17 over 4 and the midpoint is 2, which is super tricky. So we're going to do a little piece of work here. Again, we need some space, so I'm going to go ahead and figure that out. So 17 over 4 is going to be the midpoint. So we'll say 17 over 4 for the, so this is for the y coordinate of B, plus the y coordinate that we don't know, which is the y coordinate of D, so y of D. This is going to be equal to 2. As we divide by 2, we find the average of those two, which means that 17 over 4 plus the y coordinate of D is equal to 4, which means the y coordinate of D is equal to 4 minus 17 over 4, and 4 is 16 over 4, so 16 minus 17 over 4, we get a y coordinate of D here. Again, this is on rough paper, which is negative 1 over 4. So 16 over 4 minus 17 over 4 will give you negative 1/4. And that is good for this one, negative 1/4. So huge question here. So 3, 17 over 4. Let's write these down. So 3, 17 over 4, and then negative 3, and then negative 1 over 4. Now, if you've managed to do a question like this, you can definitely pat yourself on the back because this is how you get a 9. There's no question about it. Okay, so for question 23, it's only a 2-mark question, so it shouldn't be that complicated. So there's a sketch of cosine of x over 2, which is, if you think about it, this is the cosine function stretched horizontally. This is a stretch factor that's horizontal, and the stretch factor is times 2. So why is it times 2? Because whatever happens inside the bracket is horizontal and reversed. So inside the cosine bracket, you have x divided by 2, which means it's extended and stretched horizontally by 2. Now, usually, cosine of 90 would be 0. So this is your standard thing, is that cosine of 90 is equal to 0. However, in this case, if we have 90 divided by 2, that'll be the cosine of 45, and that's not 0. So really what you want is you want to be able to say that this is the cosine of 180, because 180 divided by 2 is going to be 90, and that'll be a 0. So x here is going to be 180, and the y coordinate is 0. This is because cosine of 180 divided by 2 is equal to the cosine of 90, which is equal to 0. So knowing that cosine 90 is 0, this is what gets you the mark here. Okay, for the point B here, important to realize when the cosine is equal to -1, and so the cosine of 180 degrees is equal to -1, typically speaking. So if we wanted to generate 180 with a function that's been stretched across by a factor of 2, think about the cosine of 360 divided by 2, which is also going to be equal to -1. So the answer to the second part is actually 360, -1. And so the skill in this question is to understand stretch factors for functions, and in this case it was a horizontal stretch of factor 2. But the other skill to consider as well is, do you understand the cosine function? And if you do, then you'll know that the cosine function reaches a 0 at 90 and a -1 at 180. If you weren't sure about why this is the case and those values are good, please remember that you're absolutely allowed to use a graphic calculator, and so I've taken the liberty here to graph this on Desmos for you. And as you can see, so the function x over 2 reaches a 0 here at 180 and reaches -1 here at 360. Now that's good for that function, and all you need to do is to graph it on your calculator, and that's okay. And you can realize here that the cosine x function instead reaches a 0 at 90 and reaches its minimum function, or its minimum value, at 180. So the minimum of the function is always going to be -1, but one version, the red curve, is stretched by a factor of 2. And so this is the big difference between these two curves. Moving on here to question 24. This is a question which has some powers of 3, it looks like, and we need to express x in terms of n, which really means solve the left-hand side. So solve this side, this is the left-hand side. Since the right-hand side is a power of 3 already, solve the left-hand side for n, and you should be able to get there. Now, something that's very obvious is that there's a lot of 3's in there, but 18 contains a 2 and 6 contains a 2. And if you were just to do 18 divided by 6 to start the question, that would really simplify your work. So we could say 3 times, so instead of 18 over 6, we could say 3 times, and then the square root of 27, so we can say 27, let's say the square root of 27, which is 3 cubed, to the power 4n plus 6, divided by 9, which is 3 squared, to the power 2n plus 8. So this is going to be equal to 3 to the power x, and we're going to try and simplify this left-hand side as much as possible. So the next line is going to look a little bit like this, 3 times, and instead of square root, we can apply the power 1/2, and so we're going to say that this is 3 to the power 3 times 1/2, and 3 times 1/2 is 3 over 2. And this is still to the power 4n plus 6. So using the fact that square root of x is equal to x to the power 1/2, this is what we're using here, just to make sure that you know what just happened. Okay, so this is great. And the bottom is going to be 3 to the power 2 times 2n plus 8. So when it's to the power, you need to multiply. So 3 to the power 4n plus 16 here. Okay, so we're still doing good. In our next line, we'll probably have to use the fact again that a to the n to the power m is equal to a to the nm. And a piece of work that you could do on rough paper here is to think about what 3 over 2 times 4n plus 6 looks like. And 3 over 2 times 4n plus 6, well, you can say that's 3 times 4, which is 12. 12n's divided by 2, that's 6n. And 3 over 2 times 6, so 6 divided by 2 is 3, 3 times 3 is 9. So this is going to be 6n plus 9. And that's what's going to happen to the power in the numerator. So we can say 3 times 3 to the power 6n plus 9. So that's multiplying 3 over 2 by 4n plus 6, divided by 3 to the power 4n plus 16. So in our next step, realizing that we have here 3 to the power 1 times 3 to the power 6n plus 9, we can actually say that that's 3 to the power 6n plus 10 divided by 3 to the power 4n plus 16. And this is because a to the power m times a to the power n is equal to a to the power m plus n. So adding the 1 to the 6n plus 9, we get 6n plus 10 because they're multiplied by each other. The next law we're going to use is that a to the m divided by a to the n is equal to a to the m minus n. And we can use that in our next section here. So 6n plus 10 minus 4n plus 16. So this is going to be equal to 3 to the 2n, so 6n minus 4n, and 10 minus 16 is minus 6, and this is equal to 3 to the x. And since these are both powers of 3, you can conclude with x equal 2n take away 6. And this is a great place to stop for this question. I believe this is the end of the paper. And this is where you're so happy that you're done. Oh my, wonderful. You guys did great. Thank you so much for sticking through with this one. Thank you so much for doing it. Absolutely amazing. You did it. We're finished. And what we can do here is make sure that any questions that you haven't understood properly, you review a little bit, and make sure that you practice similar types of questions. So if you're stuck on a question with vectors, then I recommend that you pick out like 5 or 10 questions that have to do with vectors and go ahead and do those. Catch us in our next video for some more past paper solves. Until then, good luck with your exams. Remember, math comes easy with the Mathemagic Channel. We're trying our best to help you here with your past papers. And so go ahead, give us a like, a follow, and a subscribe, and we'll keep putting these out for you. Thank you so much. Good luck.